Uh, Good evening, everyone. I am deeply honored to be here in the online, and I would like to thank the organizers of Study World College of Engineering and the EEE Department organizers for this wonderful opportunity to address in front of the distinguished professionals, academicians, and dear students. Uh, I always start with the words of Albert Einstein. Imagination is more powerful than knowledge. Today, I want you guys to explore how your imagination can drive your future. Okay. See, before starting into it, I will tell you about the story of electric vehicles. Before 10 years, start with 2012 or 2015, Mahindra Reva is the electric car, the two-seater car, the first electric car. It is standalone in purchase. In a short 10 years of on a single decade, all the electric vehicles are booming like anything, like say two-wheeler or three-wheeler or four-wheeler or aerospace. Everywhere electric vehicles are came into picture. Before 10 years, you see that everyone is petrol or diesel. Now in a decade, you see a tremendous development in the electric vehicles, batteries, connected vehicles, all other advanced technologies. So we are in a position to transform ourselves. So think in a way, go in a positive manner, and go green to make a globe clean. Okay. So before getting into that, I had to explain about my company Tata Elxsi, where I'm working here, and about Tata Group Business Empire. Everyone, who's the richest man in the world? Everyone will tell about Elon Musk or Jeff Bezos or so many people like Warren Buffett, but no one will tell about Ratan Tata. Unfortunately, we lost our Ratan Tata, but Newell Tata will take care of the chairman of Tata Trust now. So more than 403 billion with 30 publicly listed companies, the man with vision of all the things. So here you see that. Okay, you see that starting from the durables to aerospace. So I am part of from the technology side, from TCS, Tata Elxsi, Tata Technologies. More companies are there. So from this technology group, I am from Tata Elxsi. So it's completely different from the Tata Consulting Service. So we are having three verticals majorly we working on it. So media and communication, transportation, and healthcare. In media and communication, we working on OTTs, streamings, advanced TVs, customer experience, user experience, and in communication 5G, network transportation, and digital transformation. So complete media and communications, we taking care of it. In transportation sector, we are working in automotive, particularly on the passengers experience, connected and autonomous vehicle, shared electric vehicle. And we are not only on that, we are working on the rail for industrial service design and rolling stock. Not only on that rail, we are also working on the aerospace industries. And the third vertical is the healthcare system, the media devices like product design, system engineering, and regulatory compliances, and pharmaceutical like safety, drug delivery, and packaging and labeling. So these are the three major verticals we are working on it. I am part of transportation team. In the whole Tata Elxsi completed of more than 30,000 engineers. I am not saying the employees, 30,000 engineers who exclusively working on the design and engineering part. The company started in 1989 and the global headquarters in Bangalore. We are into business with 30 years of business and 36 locations in world cities and worldwide we are having the presence. So with this short introduction about my company and Tata Group, I'm getting into our today's topic is green mobility and electric vehicles in urban planning. Green mobility refers to the friendly way of moving people and goods, reducing the negative environmental impact of transportation by lowering the greenhouse gases. The main objective of the green mobility and electric vehicles in urban planning is to environmental protection, energy efficient, and sustainability. These are the three key principles of green mobility, so that the electric vehicles and in the urban planning. Yeah. Hello. Sandhya, I'm audible, right?
Sir, you are audible, sir.
Yes, yes. Okay, okay. I think I lost internet connection. Okay, no problem.
No, sir, no, sir. You can continue.
Okay. Yeah. So we'll begin with an overview of green mobility, then dive into the EV trends, government policies, infrastructure integration, challenges, opportunities, and case studies on global benchmarking and future perspective and recommendations, following with the conclusions. The overall aim of this study is to how the infrastructure and planning integration, particularly on the urban side, towards green mobility. The word green mobility is refers to sustainable transportation that minimize the environmental impact, which means we starting with the uh, exploration of evolution of cars and automobile makers starting from 1886. So the engine will start at the 1886 itself, from steam engine, after that gasoline engine, after that diesel engine, after that hybrid, in that hybrid, plug-in hybrid, full hybrid, then electric vehicles, pure EV, then hybrid cars, followed with the hydrogen engines. So in the hydrogen, particularly the hydrogen part, two major are now evolving. One is the fuel cell technology, second is the hydrogen engines. So starting from the steam engine, currently the automotive sector is more focusing on the hydrogen by using the hydrogen gas as an input for the hydrogen engines, so that reduce the emission and reduce and increase the efficiency of the vehicle without reducing the market standard. Which means, for example, the world of electric vehicle, the electric vehicle came into picture now. So all the diesel engines, petrol engines from starting from 19th century are going to ruled out. But if think about that, the world is going to an advanced sector. If the advanced sector moving in ahead of that, so that all the people from the component manufacturing, nuts, bolts, all have to lose their job if electric vehicle came into picture. So what the advancement in this, that without completely neglecting the engine of the last 19th century till now, so we are using that now. The advanced technologies are using the hydrogen gas or hydrogen came into the as a fuel to produce the last mile connectivity. So this is the way the transform from steam engine to hydrogen part. In a particular topic in green mobility, it refers to the sustainable transportation that minimize the environmental impact, which includes electric vehicle, public transport, shared mobility, and promote alternate fuels, fuel cell technology, and non-motorized transport. So the all came into for the picture where we can the most aim is to the goal is to reduce the carbon footprint, improve the air quality, and enhance the urban livability. For example, in metro cities like Delhi or Mumbai or Chennai, like that, the people always travel in a car, bike, or any two-wheeler or three-wheeler. So much of carbon dioxide emission. Majority of the carbon emission from the urban is contributes to 40% of the impurity gas from the urban only. So we have more concentrated area, so that we have to reduce the green mobility and electric vehicles in urban, so that automatically the emission will reduce, so that that livability of the human behavior will increase and improve the air quality, and as well as the reduce the carbon footprint. India ranks among the top 3 countries for transport related emission. There is an urgent need for the transition right now. That's why India makes by 2030 there is no diesel car. People have to go with the either electric vehicle or hybrid, and some car with the petrol. In public transport like metros, buses, EV buses, now you can see that all the commercial olden ways the diesel buses are replaced slowly by electric vehicles. So why? Because of to reduce the environmental impact by the that carbon dioxide and other substances. So this is about the public transport. We have to develop the infrastructure and maintenance and depot. All the other things came into picture here. In shared mobility, like for example, if you go for Western countries, if you go by a car in a solo, for example, if you have an SUV, if you go by solo, they are charged more if you enter into some a part of the areas of any companies are like that. Though, so that shared mobility came into picture, for like two-wheelers and three-wheelers, the sharing of, so that the environmental effect of carbon dioxide can be reduced, so that the shared mobility came into picture. Similar way with promote alternate fuels. As I said earlier, hydrogen, fuel cell technology, electric mobility for the better environment. So non-motorized transport, which is nothing but cycling and walking. We don't have any specified paths for cycling of that, or who are all walking, so that the environmental, greener environmental getting more and more, we can utilize the green energy to the future. So this is about the short introduction of the green mobility. Then we will go with the electric vehicles. Electric vehicles, you see the graph here, our India map. UP and Maharashtra are contribute more than 30% of the electric vehicles in India, because in UP and Maharashtra are more polluted, so the government norms are strictly giving enforcement to reduce the olden age vehicles or diesel vehicles or emission norms are strictly they are following, so that UP and Maharashtra are more towards the EVs, particularly on the electric vehicles like two-wheeler and three-wheeler rickshaws, or small passenger goods carrier vehicles like that. So similar way, Tamil Nadu is also going into the follow the EV trends. So, but the first three states are UP, Maharashtra, and Karnataka contribute mainly 30 to 40% of the electric vehicles in India. Here, that rapid growth of the electric vehicles, the EV sales surged with over 40 million of electric cars on road by 2023, and forecast for sales to continue significant year-on-year increases. You see that from 2018 to 24, there's a drastic increase in the vehicle sales. It will be two-wheeler or three-wheeler or four-wheeler or buses. So, but 2020 to 24, there's a slight reduction. This is because of the magnet and the batteries. So basically, we are relying on batteries from the China and motors. For example, in electric vehicle, the two major components is the battery and the motor. So for these two components, we have to rely on the other countries, so that people for going for for example, if you go on any car, if you want to purchase in India, we have petrol version, diesel version, hybrid version, electric version. So 4 different versions are there, or 5 to 6 different things are for a same model car. So we have to choose which one have to go for within our budget. So for example, if the government promotes to go for electric vehicles, but the batteries and magnets from other countries, they slow down due to some political power or something, so that we will stop getting the batteries and motor from the other countries. So that's why there is a slight surge in the year while the electric vehicles came into picture. So as per our Indian GOMS, CAGR of 40% from 20 to 2030, over 28 lakh electric vehicles are registered as of just 2023-24. So our target is 30% of new vehicle sales to be by 2030. And this is a projection of how the electric vehicle registration in India from 2013 to 24. So there's a tremendous rapid growth in the electric vehicle market from here 2020 to 23. So expanding market shares. The shares of new car sales that are in electric has risen drastically, and the key drivers for this tremendous growth is that government incentives, environmental goals, and technological advancement, such as improving the battery performance, cost as a major factor fuel this growth. Along with that, as electric manufacturers are increases day by day, parallelly the infrastructure have to develop. We have infrastructure in the sense charging station, swappable batteries, and how we have to charge our batteries, electric vehicles like that. So infrastructure in a parallel hand, infrastructure have to be developed more, as well as the electric vehicles contribution from the EV markets. So this is a complete electric vehicle overview and trends in India. So regarding that government norms, Indian government and policies and initiatives, starting from 2012, we are in now 2015, starting from National Electric Mission Plan 2020, starting from this 2020 to 12 to 2025 now. So the amendments made on different stages in different years. The main goal is to reduce the environmental impact by reducing the carbon footprints and improve the air quality and following with the energy efficient. So the three parameters is the key focus from 2012 to now, but stringent norms coming, everything mainly focused to address these three important goals on that. So that is called FAME, faster adoption of hybrid electric vehicles. FAME 1, FAME 2, and FAME 3 came into picture. This is nothing but so faster adoption of hybrid. So government initiates and incentives for the automobile makers to start building on the hybrid cars, electric cars, so that the market will be getting higher for the electric vehicles. So this is some of the government in upcoming slides. We can see that what are the government initiatives by the central government and state government like that. The one 2020 you see that is the main breakthrough of that. Our DHI is the charging station in phase 2 and FAME India scheme launched to accelerate the production and adoption of hybrid electric vehicles, aiming for the national fuel security. India, the FAME is this FAME scheme is the India's flagship scheme, providing demands, incentives for electric hybrid vehicle and supporting the manufacturing ecosystems in phase 1. If you phase 2 of the scheme indicates mainly focused on the phase 2 is mainly focused on the 2-wheelers, 3-wheelers, and 4-wheelers and e-buses and e-trucks. That's why, for example, if you come into Bangalore, most of the olden age vehicles are ruled out. Slowly for public transport, electric buses are came into picture. Similar like e-trucks. E-trucks includes small, less than 2 ton, 2 to 4 ton. Now all the 3-wheelers are coming to like 3-wheelers are morely converted into electric vehicles. This is by giving more incentive for that vehicles. This is the government initiatives and tenders and private partnerships are came into picture. So enhance the phase 2. Then phase 3 is going to approach for that scheme. The phase 3 includes the government now industries. Here you see that 10,000 crores government invested for initiatives for EV infrastructure and the EV purchase, and national mobility mission plan that includes long-term roadmap for boosting domestic EV manufacturing. Nowadays, if you see that for lithium, for example, lithium-ion battery, coming to lithium-ion battery, we have major giants like Exide, Amaron, and so many companies are came into picture. But still, we are relying on the batteries from the other countries. So, government initiatives to have a production plant, support for the batteries who manufacture domestically inside the country itself, and PFP program also like that to promote local EV component production. So, localization, the word localization. So, where the parts coming from the electric vehicles from overseas can able to manufacture inside our India as per the norms that promote local EV component production, the duty store reforms, and state-wise EV policies for Delhi, Maharashtra, Tamil Nadu. So local incentives and infrastructures, particularly other than the central government scheme, state governments are enforcing, are giving more incentives for who are all working on the 3-wheelers, 2-wheelers, particularly on the electric vehicles. So this is a Indian government policies and some of the initiatives here. Coming to the next slide is the national mission for transportive mobility and storage. Before that, I'm talking about the central schemes. See, FAME 3, 10,000 crores and 15 kilowatt subsidy for 2-wheelers and 3-wheelers. PLI scheme, like that PLI scheme, it is production linked incentive scheme for advanced cell chemistry, battery storage to boost the electric domestic production. Coordinate with ministers, departments, state to align the integrate mobility initiative. These are some of the initiatives from the central scheme. Statewide scheme like Delhi, that is 10,000 kilowatt plus tax exemptions. In Tamil Nadu, EV manufacturing zones with giving more and subsidy for the like power consumptions for the companies who manufacture electric components as well as battery or other allied components who is working for the electric vehicles. Maharashtra like 1.5 lakh subsidy on EV cars, as well as on the GST. Coming to the GST on the EV side, giving more flexibility like 5%, 20% of internal combustion engine plus 1.5. So much percentage of tax revived for the electric vehicles. Coming to the roles and responsibilities of impact, that the roles coming to the for national mission is to develop strategies for transporting mobility and phase manufacturing and components. See, as I said earlier, if the electric cars are developing like anything, Similar way, government have to go for the infrastructure development for. See, for example, if you want to travel from here to for Tamil Nadu, particularly in Tamil Nadu, if you want to travel from Coimbatore to Kanyakumari around 400 kilometers, you have to charge at least single time or two time in between that. It will take 8 hours. The superchargers is there, fast charging is there. But if anyone go for pushing the batteries so much earlier, like fast charging, you are degrading the battery life also. So government initiates for battery charging performance, cell level performance, and infrastructure. So they have to now proceed with that, coordinate with the ministers and departments and allied private concern to align with the integrated mobility initiatives. So this is a role that roadmap gives with that. The government establish giga scale integration of cell manufacturing and promote comprehensive growth of Indian battery industries through PMP scheme. And finally, the impact of the roles and roadmap will clearly have to reduce the urban pollution and oil dependencies and boost adaptation of renewable energy and advanced storage systems and promote ease of living and job creation through Make in India. So this is the complete roles and roles, responsibility, and the impact of the government schemes by and the state level initiatives, so that the Indian government policies now keep on flexible to the middle class and 4 meter segment vehicles and so on. There's some now why it matters in urban planning. The urban planning contributes 30%, 35% of Indian CO2 emission. With rapid urbanization, green mobility is no longer optional. It is essential and must to have a green mobility. Green mobility contributes by electric vehicles and hydrogen. We are very niche to the hydrogen circulations. Now, government initiatives focus on particularly on the electric vehicle. The key theme is that the Indian urban populations exceed 40% by 2030. If you come to Bangalore, if you come to Chennai, before 5 years, the drastic amount of urban populations increasing day by day. So the Indian expectation of 40% exceeds by 2030, driving demand for integrated infrastructure. So cities as engine of growth need for multimodal mobility, smart utilities, and recentering planning. And finally, support by national frame like National Urban Policy Framework, Smart City Mission, Urban Challenge Funds, backed by ADP. So some of the these are the national frameworks to develop for the urban driving demand for integrated infrastructure, and it's coming to way forward for the urbanization. So some of the project needs requires $840 billion by 2035 for urban infrastructure, but annually invested for, as per our target, is 55 billion per year. The overall project objectives outcome from that urbanization is expected outcome: the improved urban mobility, air quality, and housing access, enhancing resilience to climate change, then job creations through infrastructure lead growth. So these are the why this urban planning is matters to the electric vehicles and green mobility. Yeah. So amendment model building law by law mandate EV charging in 20% of parking spaces. So government laws are enforcing, like if you have an apartment or if you have a standalone building or any corporate office, charging station is mandatory, and you have to give subsidy for who are charging there inside. And if you buy an electric car, for example, in overseas and all, if you buy an electric car, toll free, parking space free, and if you have any toll plaza or something, that toll plaza you have to abide. So that government initiates to promote the electric vehicles and also the charging stations. Coming to the infrastructure integration, EV charging station in residential and commercial buildings and land allocations of geospatial planning for public charges. Integration with electricity grid and DISCOM coordination, and roles of smart city and MOH plan. So cities like Bangalore and Delhi and Hyderabad start with the smart traffic system. So it's not like the regular way of traffic signals. It's like smart traffic. So whoever has densely populated or who have very congested, very highly thickly, the motor vehicles are into signals, means it's open accordingly to the user side. So 20 plus public charging stations inside Delhi alone. So the planning must include grid upgrades for EV loads and battery swapping stations. So integration with metros, bus, and NMT networks. So there are roadway for multi-stakeholder engagement for the city level EV adaptations. So regarding that, government taking infrastructure advantage and planning integrations for urbanization. So the majority is like, this is how the companies or governments taking initiatives from the infrastructure and planning integration. First is sustainable architect and design, ensuring the building design minimize the environmental impact. Second is the site selection and planning. So for a planning approval of any vehicles, or planning approval for any buildings, it should be have the parking space as well as the geological site to reduce ecological disruptions there or not. The site selection planning is a very important role for that. Third thing is the water conservation. So recycling of the implementation system to reduce water usage and promote recycling. And fourth, the indoor environmental quality. And fifth, the building materials and resource. And sixth is the energy efficiency. Finally comes with the innovation and design. So this is the complete plan from starting of evolution of sustainable design to the innovation design. So the overall thing is to reduce the carbon footprint, because urbanization is day by day that people from the moving to the urban areas is keep on increasing. So government gives strong stringent initiatives to reduce the consumptions. So this is a category where greenhouse practices and saving potentials. This image will show about the what are the list of categories and list of green warehouses practice. For example, energy cost, people working on the government and peoples and private sectors, buildings on the top floor with solar panels, LED lighting and HVAC. These will increase 20 to 30% saving on the electric bills. Similarly, with water cost, rainwater harvesting, waste management, operational efficiency, and maintenance costs. This is some of the category, so that the savings of the energy play a major role. So starting from 20% to 30%, if you work on each categories, so we will save 39 to 40% saving the total energy consumption per month. Similarly, with savings in the 28 to 30% of savings in water consumptions and 32 to 35% of in reduction in total embodied energies. And if you invested anything within 2.5 to 4 years, the average payback period for the return on the investments. So this is the category will show about how we can reduce the energy consumption and operational efficiency and maintenance costs, so that how our improvement in total energy will enhance. So the overall expected outcome from the urban infrastructure and planning is that, so sustainable transportation, accessibility to nearly 58% of urban mobility, which includes pedestrian walk, cycle tracks across 130 cities, and public transport facilities improved and cleaner across 106 cities, and 1,000+ kilometers of BRT network across 28 cities. So this is a way from urbanization, financing, and institution strengthening across 35 in India. More than 53 cities are setting up the UMATA across. Then permanent funding for UT financing at OEM, and real-time and PIS, AVL, cashless ticketing across 130 cities. So thereby will increase the alternate fuels across cities like paratransit and buses, and all e-mobility came into picture, and the people utilizing the shared mobility will increase. So this is about the urban infrastructure and planning integration. So coming to that challenges in green mobility and EV integration includes insufficient and unevenly distributed charging infrastructure, high cost, and grid strain from the increased power demand, and policy gaps and regulatory incentive. There are some of the main challenges addressed here. Is coming to the infrastructure deficiency, the challenges include the major hurdle is the lack of widespread and reliable charging infrastructure, including insufficient public charging stations and grid capacity use. Regarding the high cost, the upfront purchase price of EV remains a barrier for many consumers. For example, if you want to buy, for example, in Indian, want to buy a Nexon car in petrol, it costs around 12 lakh. If it is go for a diesel version, it is 13 to 15 lakh. Now, if you go same with electric vehicle with the Nexon, if you go with an electric vehicle, it costs around 15 lakh above. So it is a main price barrier is one of the key challenges for maintaining the developing the ongoing cost of the purchase the vehicle. So the high cost, because of the high cost, the main two reasons is the battery and the motor. So if you have a battery with high performance, the cost will drastically reduce. Then similar with the grid strains. Grid strains includes the increased demand of electricity from EVs can place additional strain on the power grid, potentially leading to the instability and need for significant upgrades. So if you think about that, if urban population in that urban area in morning in a peak hour is 7:30 to 9:30. In that 7:30, more than around 10 lakh or 5 lakh vehicles in urban vehicle. If you put a continuous charge on the grid, it may disturb the entire grid system. So that the increased demand for electricity EV can place additional strain on the power grid. So this is one of the challenges here. And policies and regulatory issues. Usually the lack of clear, consistent state government policies and regulations can hinder the infrastructure development and EV adaptation. Another one of this is public acceptance and awareness program. Citizens are, in our case, hesitant to adopt EV due to the lack of awareness. In our case, as a consumer point of view, we are more relying to work on the two-wheelers rather than four-wheelers because of the cost. For example, if you go by any two-wheeler like petrol version of two-wheelers around 1 to 1.5 lakh. Similar way, if you invest like 1 to 1.5 in electric vehicles, the cost compared to the petrol engine and the electric vehicle is more or less similar, so that people more afford towards electric vehicle. Similar way, if you go for electric vehicles like four-wheelers, petrol and diesel car are somewhat drastic increase in the compared to the electric vehicles are more higher. So that the awareness, so people, the lack of clear and consistent, stable awareness, transparency, and understanding the benefits of as well as concern like range anxiety. See why? Because in electric vehicle, more than think about it, it's a two-wheeler, we can max is per day is 50 to 60 kilometers per day. Think about that. The same thing if you go for electric vehicles, we usually go for more than 100 kilometers in a week or something like that. So the range anxiety is giving a bad thing for our electric vehicle, in particular on the four-wheeler adoptions. Similar way, battery technology limitations, the cost, weight, and limited range of current EV batteries still present challenge to the battery technology. Like coming to that opportunity side, so the opportunity side, the environmental benefits, the main important thing of the whole context is the environmental benefit. See, EV produce zero tailpipe emission, leading to improved urban air quality and reducing noise pollution and better public health outcome. So the main root cause and opportunity, if you follow the government initiatives, people have to convert the mindset of traditional engine to electric vehicle, and lot of incentives have to given by the governments, privatizations like that, so that the overall environment benefit will increase and reduce the fossil fuel dependencies. If you have a wide spread of EV adoption, can decrease a cities and countries reliance on import oil and gas, enhancing energy security. And third important thing is the enhanced urban resilience. The EVs can help build more resilient transportation network that are less vulnerable to disruptions from external shocks such as pandemics and extreme weather. Then development of integrated mobility. In that case, a shift of EV presents an opportunity for urban planners to design more integrated and multimodal transportation systems that combine walking, cycling, public transport, and shared EV systems. These are some of the development of the integrated mobility, so that the opportunities came into more for our as a consumer point of view as well as the environmental point of view. Then smart city integration. The EVs can integrate smart cities technologies to improve energy efficiency, manage traffic flow, and even provide energy to buildings, building to building, building to business, and creating more dynamic urban environment. So coming to the innovation and economic growth, EV sector fosters innovation in technology, energy, and smart city solutions, potentially creating new economic opportunities and jobs. Here in some of the bullet points will show that EV exports, we are getting into more business and charging infrastructure and battery as a service model, like similar way like two-wheeler swappable battery. Similar way in upcoming future, four-wheelers also have tried to adapt for the battery as a service model. And skill development, EV mechanics and fleet operators. So these are some of the major opportunities coming from the through urban electric green mobility and electric vehicles. These some of the case studies and global benchmarking in India, developing of 2000 in Delhi, particularly in Delhi, 2000 charging stations, battery swapping hubs, because Delhi is in the whole India, Delhi compute most of the pollutions and improper air quality and lot of problems in the urban planning. So that's why government more focusing on the Delhi's to invest on the charging stations and battery, so about to reduce the pollution and improve the quality of the air. Similar way with the global things, for example, in Bangalore also 800 charges and smart traffic integrations. So each states and each places with wherever the urban pollutions or urban how is happening there, we have to concentrate more on the charging stations, electric vehicle adoptions, and incentives. These three will parallelly integrate so that the pollution is drastically reduced. Similarly, with the global thing like Norway and Denmark and France, so some of the countries having strong EV hold and their tax incentives also, and charge platform with 1,600 EVs across cities. So some of the countries are now strictly following adopt conversion of the drastic vehicles. I mean, kind of a drastic petrol and diesel into electric vehicles. Still electric vehicles into hydrogen vehicles also. In coming to the hydrogen vehicles, fuel cells or hydrogen engines. So electric hydrogen engines also came into picture now for the particularly on the commercial vehicles. For so all the things, electric vehicles or two-wheelers and three-wheelers are gaining more attention. Similar way, hydrogen vehicles are large-scale vehicles like not for the passenger car, for the trucks and high power vehicles and mining equipments like that, because of that storage system. Upcoming stage is about start slide about the hydrogen business also. So this is about these challenges and opportunities for the electric vehicles. Then coming to the future perspective, recommendations and conclusions. So India aims for net zero by 2070 and stakeholders by achieving this transport. By 2030, target 30% EV penetration and 50 gigawatt of non-fuel fuel capacity. So coming to the integrated future of urban planning for green mobility centers, and the integrated approach that combines a robust EV charging infrastructure with sustainable public transport, active travel, and smart capacity cities designed to create live and low carbon recommendations. These recommendations includes accessibility, affordability, and integration of autonomous electric vehicles, that is called AEVs, and development of circular economy for batteries and supporting multimodal government's policies. So the main thing in the future perspective is expand EV charging infrastructures in tier 2 cities, and particularly in the future perspective, the integrated mobility ecosystem. The future vision of India is just to about EV, but a complete shift to shared, connected, clean, and intelligent mobility system. The word clean means that zero tailpipe emission. That intelligent mobility system means AI integrated, autonomous vehicle, connected cars, like that. So similar way for another future perspective is the smart cities and AEVs. The AEV stands for autonomous electric vehicle. It will play a significant role in enhancing traffic efficiency and reducing congestion and improving urban safety and flow. And another future perspective is vehicle to grid integration. That vehicle to grid means the EV can become an integral part of the energy grid, storing renewable energy and helping to balance energy and supply and demand. Coming to vehicle to grid is nothing but, so the new concept called the battery energy storage system. They are investing more than 500 gigawatt of energy storage system. For example, before 10 years, solar panel is there. So solar panel, electrolyzers, everything is there. It's a wind energy, particularly on the solar and wind energy as the renewable energies. From solar perspective, the peak power is produced on the daytime, and it is utilized stored on the grid. From power production from solar as well as wind, produced power is connected to the grid. The loss is higher, and also whenever we require, for example, it is a 4 month of rainy season, there is no daylight or sun like that, so we are shortage of power, as well as wind is not there, there is a shortage of power. For that, battery energy storage system came into picture. So for example, if it is a particular building, is as a for the standalone building is there, that rooftop is fully completely flooded with the electric solar panels, and the windmill is there. The power produced is stored on the battery. It is nothing but This is a power bank. Like what we have for example, if we have a power bank like solar power bank, we have it for mobile charging. Similar way, bigger batteries like 1 kilo, 2 kilowatt, 5 kilowatt, 10 kilowatt, 100 kilowatt, even megawatt level battery storage systems are produced. So it may have some different occasions. You can power produced from your building can store to the battery, and the stored battery charge can be utilized whenever it is required. So that daytime or rainy time or night time, we don't need to bother about that. So now regarding that smart cities, this is also one of the key initiative by the government, like developing infrastructures for the battery electric energy storage systems for the to replace the vehicle to grid. And circular economy, the strong emphasis will be placed on managing the life cycle of batteries to recycling and repurposing to create circular economy. For example, in that case, so for example, if you go for electric vehicles, the battery is used. That battery, if it is 5 to 6 years, they are manufacturers giving warranty. After that, we can utilize for giving the second life of the battery. It is nothing but we can put it under some storage systems like UPS battery, some second life it is giving for the car automobile batteries, particularly lithium. And final thing is how to recycle the battery without creating any harmful gases and hazardous nature. We have to recycle the battery. One biggest problem in electric battery is that only 20% of the batteries can be recycled. Remaining everything is carbon, because the batteries lithium ion component, lithium is the main metal. So if lithium metal subject to open atmosphere, it catches fire. So nearly 20% of the complete battery components can only recycle. Remaining 80% is waste management or waste energy. So government initiatives and expand EV charging infra, particularly on the tier 2 and 3 cities, and promote green logistic like e-buses, CNG, and green warm housings, and etc. So encouraging EV R&D also, and local battery production like localization of battery in India. Similar way, EV R&D. So EV R&D includes performance of the battery and reducing the slippage and increasing the energy efficiency of the battery thereby, and also the local productions. So the complete integrated EV into smart city framework. So some of the recommendations for the EV battery. So another recommendations for the urban planning, particularly on the electric vehicles, infrastructure development, that charging network, smart infrastructure planning, and integrated planning and connectivity. That holistic mobility planning that includes electric mobility into a broader strategy that enhance the public transport, encourage walking and cycling, and accessing the urban environment that are more compact and accessible. So regarding the policies and governance, supportive policies implement strong government policies, incentives, and subsidies to accelerate EV adoption and encourage private sector. So multi-level governments also came into picture to create cohesive and effective policies. So some of the key conclusions here is that from the green mobility is not just the environmental impact, it is an economy and social opportunity. The green mobility and EV adoption lead to a significant reduction in the greenhouse gas emission and pollution, improving the urban air quality and contribute to better public health. So in the particularly on the economic side, the growth of EV industry, renewable energy systems creates a new job opportunities and stimulates economic activity and making cities more attractive for investment and talents. So if you it's like battery and electric vehicles, not so if we think about the battery, it's the combination of electrical engineers, chemical engineers, mechanical engineers, automobile engineers. So the single word electric battery, I mean lithium and battery, comprise of all department of energy is going to came into picture. That's why that economy giving more job opportunities and stimulate economic activity, making cities more attractive for investments and talent. And second thing is the infrastructure. The EV journey is accelerating, but success depends on the urban planning, policy support, and public engagement. Like infrastructure needs, the comprehensive and accessible network for charging infrastructure integrated with renewable energy source is essential for supporting the widespread adoption of EV. So the infrastructure has to be needed, and policy and governance, and social equity and accessibility, and integration and collaboration. Integration and collaborations is nothing but the successful integration of EV require a holistic approach that combine infrastructure development, supportive policies, technological advancements, and broader stakeholder management, including public awareness campaign. With the strategy and investments and inclusive planning, India can lead the global green mobility. So these are the conclusions from the future's perspective and recommendations of the electric green mobility and electric vehicles in urban planning. So with this short thing, I'm going to give some important updates on how the future of mobility. So future of mobility not only relying on the electric vehicles, it is like hydrogen. Particularly, now all the OEMs are working towards hydrogen. So last 10 years, electric boom like anything. So another decade, so transform of future technology is nothing but the hydrogen source. Use of hydrogen energy from hydrogen. See, you see, hydrogen is everywhere. So not only on the water, you can get more hydrogen from sugar molasses, water, salt, anything you have hydrogen. Wherever H is there in the element, so we can produce hydrogen. So towards the transport of automotive is completely transforming. Now future is towards electricity, hydrogen. So another decade, for example, how we see that 2012 till 2025 drastic changes in the electric vehicle. Similarly, from 2022 to 2035, the drastic evolution of hydrogen engines and fuel cell technology came into picture. So with this small, I ask another 10 to 15 minutes of the slides so that it will discuss about the futuristic technology. So now it's completely different. So future is next generation power source and mobility solutions. That is energy, efficiency, economy. Fuel cell technology, that is the term. So what is fuel cell technology? Major differences battery and FCT, and advantage, disadvantage of current battery electric vehicles, and why BEV and FCV are not popular in current market. So these are some of the 4 major tasks we are going to discuss in the upcoming slides. So these are the hydrogen FCV system, fuel cell electric vehicle. Fuel cell electric vehicle means we completely replace the engine with the fuel cell stack. Battery is there. The main difference of electric vehicle and the fuel cell electric vehicle is the electric vehicle, you need to charge the battery outside the car. In fuel cell electric vehicle, the energy is produced inside the vehicle itself. It's like a fuel cell is nothing like a power plant. It generates electricity whenever you supply hydrogen gas and oxygen gas into the system. So the only byproduct is the water. So the major components in the FC system are the control units, electric motors, and fuel cell stack. That is the heart of fuel cell. That is the fuel cell electric vehicle's heart. Then hydrogen tank. Similar like CNG gas, petrol, diesel, we have a hydrogen storage tank on the rear, so that the hydrogen gas is stored using cylinders. From that, one of the input is hydrogen gas and another is the oxygen gas. From the atmosphere, we can take the oxygen gas. There is no need of oxygen cylinders inside the car. So it's combined into the electricity, where hydrogen is passed on one side, oxygen is passed on the other side. It will combine to produce water, like H2 plus O2 gives H2O. That electricity is produced. During that interaction, the power of fuel cell, it generates electricity. The generated electricity is stored in a battery, from the battery to the electric motor through control unit. So this is the hydrogen, how the fuel cell electric vehicles are working. Then this is the advantages of the zero tailpipe emission. In electric, similar like electric vehicle, fuel cell electric vehicles also, the tailpipe is pure water, where because the fuel what we are using is the hydrogen and oxygen gas, and operate efficiently, and efficiency is higher than the internal combustion engine, but not efficiency higher than the battery electric. Because okay, in a battery electric vehicle, the energy is charge is produced from somewhere, but only thing is storing in the battery. Here we are producing the electricity. That produced electricity is stored in a battery, from the battery to the motor. So the efficiency compared to the electric vehicle is somewhat lesser. But there is, for example, if no one is giving battery, no one giving permanent magnet, so that both the main 2 components electric vehicles are not given by anybody, or there is a there's a depletion of magnets and depletion of rare earth, that lithium metal. If in that case electric vehicle going to be a big problem. So the government thinking forecasting on the next decade of without using the battery lithium and the magnets. That's why hydrogen came into picture here. Because of this, the tailpipe zero tailpipe emission, and it scales up from starting from smaller vehicle to bigger vehicle. For example, it's like charging a battery. I mean, producing small power, charging the laptop to the aircraft. So starting from the, if you see the scale up easily, small vehicle to bigger vehicle, we can stack up similarly. So, and also the runs quietly because there is no moving component. Similar like battery vehicles, fuel cell vehicles also work very smooth. There is no moving component. There is no moving component, and there is no temperature in that. The operating temperature is 40 to 60 only degree Celsius only. So there is no, it's run very smooth, and it reduces the greenhouse gas emission and rapid fueling. The main drawback in the electric vehicle is the charging infrastructure as well as charging time. Here, like in electric FCEV, we can rapidly refuel the battery within few minutes. We can fill it, and then you can travel around 500 to 6 kilometers without stop anything from a single charge. So these are one of the advantages. But wherever the advancement is going, some major disadvantage also there. We are now still for electric vehicles. Now we are relying on the infrastructure development part. Here also infrastructure development, all the petrol filling station, diesel filling station, CNG gas filling station are replaced by the hydrogen storage. It's not very simple. Like hydrogen gas is the lightest one. If you stored in a, for example, petrol filling station, you have to store the hydrogen in the filling stations. You have to pressurize them. For example, LPG gas is 6 to 7 bar. Example 6 to 8, max 6 to 10 bar. It is what we have stored the pressure in our household CNG tank. Like LPG cylinders, what we are using for the cooking purposes, that is 6 to 9 bar, max 6 to 9 bar. But the tank which is stored here, the hydrogen tank, it is 350 bar and 700 bar. So technology wise, we have more advantages. Similar way is like a hydrogen stored in a high pressure tank, which means if there is any problem happen, it becomes, so initial 10 years before hydrogen blast happen, people will call it as a hydrogen bomb in a car. That's why it's before 10 years. But recent advancement is a lot more increasing, like CNG tanks and like hydrogen specified tanks. It will not blast, and it will have 3 layer, 4 layer. If any leak is happened also, it will completely engulf with the liquid something. So the day by day, the people, the advancement in hydrogen and fuel cell technology is keep on increasing. So this is a complete overview of hydrogen fuel cell system. So this is generic slide. What is fuel cell means? It's an electrochemical device similar like battery, which converts chemical energy of fuel directly into electricity without intermediate step of classical combustion. For example, convention method, the chemical energy fuel, that is petrol or diesel, anything, convert into combustion heat energy from the engine to mechanical energy. From the mechanical energy through generators, electricity is produced. So there is a multi-stage of converting the chemicals and to produce electricity. So there is each stage we lost our energy. But here in fuel cell technology, the chemical energy is directly converted into electricity with the help of fuel cell. The chemical energy is nothing but hydrogen gas and oxygen gas. The fuel cell nothing but the fuel cell stack, and electricity is directly produced with the help of, there is no intermediate classical steps. That's why the efficiency is higher. We can directly put the fuel cell into the FCEV vehicle. So fuel cell electric vehicles, like this is status and techno commercial activities. Why nowadays, why people are not afford 4-wheel electric vehicles? Because of the cost. And for example, if you buy a 15 lakh vehicle of like driven by electric battery, so the lifespan of the battery is given by the manufacturer is 5 to 6 years. People think that 15 lakh I am investing, I need to at least run for 15 years. That is the maximum given. So the people think that 15 lakh I invested, but I'll battery life is 5 to 6 years. After 5 to 6 years, I have to change the battery again. It will come into cost. That mindset have to be give awareness programs that think about the national environmental impact. So that similar way, if you buy a fuel cell electric vehicle, The same Nexon as I taken an example, the petrol is 12 lakh, diesel is 13 lakh, and electric, the same Nexon with the electric vehicle is 15 lakh. The same vehicle, if you run by the fuel cell electric power, it will cost around more than 25 lakhs. So people now very challenging to convert from petrol mindset to electric. If you think about that, electric vehicle buying 15 lakh, think about that if you're buying a fuel cell vehicle, it is 25 lakh. So people will vary, but think about that. If there is no supply of electricity, no supply of batteries, motors, or even fossil fuels like petrol, diesel, if there is no fuels into that, think about if it is no fuels, only we have the hydrogen power, means we have to go where now no other option, we have to go on fuel cell vehicles. So how the governments are encouraging and give incentives and adoption for hydrogen production challenges, and what are the main key challenges on India foray in the hydrogen mobility, and analyze an anticipated timeline and future of hydrogen business. Okay, another 15 to 20 minutes is there. Okay, I'll click shortly. Okay. So this is a hydrogen production, like 2010 to 22, the slowly hydrogen production is increasing in millions in metric tons, starting from 2051 to 89. And by type, this is not hydrogen can be shaped into different colors, like gray hydrogen, blue hydrogen, green hydrogen, brown, like that. So each color represents how the hydrogen is produced. Like green hydrogen is nothing but the electrolyzer. Electrolyzer is nothing but if you supply water is an input and the electricity that through water, the hydrogen gas is split and then hydrogen and oxygen is split down. That hydrogen gas we can take it out. That's a green hydrogen. This is nothing but there is no zero tailpipe emission as well as during the production stage itself. And FCEV. In FCEV, percent total vehicle is from 2010 is 0.11. You see, 0.11. 2022. It's 4.63 hydrogen fuels electric vehicles percentage. So within these 12 years, you will drastically see that how the fuel cell vehicles are came into picture. And percentage of FCEV at 2021, that is olden data. So from these are the main key players of using the hydrogen as an economy. So Japan, Korean, German, China, they are all investing in the hydrogen production and FCEV vehicles. They are more. The major, for example, if you talk about electric vehicles, Tesla, BYD, Tata, so many electric cars are there. Similar way for FCV, Toyota is the pioneer in making fuel cell electric vehicles. Toyota Mirai is a car segment in 2015 itself they launched actually, but in India there is only one single fuel cell electric vehicle but trial running that is running inside the India because the oxygen is taken from the atmosphere only. If you travel from northern region, we have more higher density temperature reduction and drastic temperature hike in that. So if you car travel from cold region to hot region, that air from that atmosphere is different percentage, different impurities, everything. They have to arrest everything. So the trial run is going on that. But particularly on the Japan and Toyota has the main key role in hydrogen production and FCV vehicles. So this is a chart will statistical report how the hydrogen economy is booming now, similar like electric vehicles. So this is the history of history and journey of FCEVs. The history and journey of FCEVs start from hydrogen mobility. 1788 itself started, but it drastically 2004 that Toyota launched the hydrogen powered Mirai. The car name is Mirai passenger vehicle. It came into existence like anything. See, the Japanese are very curious actually. See, Japanese, they are more investing on the upcoming next 2 decades of how the car will be, how the fuel will be. So they are more focusing on the hybrids as well as the hydrogen economy. They are less keen about the pure electric vehicles. Pure electric vehicles, you need more bigger battery. For hybrid vehicles, very small batteries required, engine power plus electric power, so that slowly they are reducing the carbon footprints. But if you're investing on the electric vehicles, and also electric vehicles during battery production, and that area it is highly polluted with that. So only tailpipe emission is zero, but the production of battery during that manufacturing area having higher pollutions. So if you arrest, particularly if you arrest there, so the carbon footprint will reduced. So for hydrogen electric fuels, electric challenges is a infrastructure challenges is the main thing. Infrastructure means hydrogen production. You have to store up during production, and transportation from hydrogen cylinders. You have to transport from manufacturer to the retailers, and then supplying from the tailpipe emission from tank to your vehicle. So all the infrastructure have to be main thing is infrastructure challenge and economic challenges. The economic challenge includes similar. I previously I told na 15 lakh for electric vehicles. Same vehicle, same condition. If you want to buy a vehicle, means it's cost from more than 25 lakhs. So people adoption is an economic challenge. And hydrogen production, energy efficiency, safety concern, and limited vehicle models and competition in the battery. See the main challenges encountered by the hydrogen engines, hydrogen fuel cells or engines came for the competition from the electric vehicles. See, if world growth of hydrogen powered vehicles, 2015 it is 1,000 vehicles only. In 2022, more than 56,000 vehicles are running on the road. It is a till 2020, but from 2022 to 2025, more than 4 times increase in the hydrogen economy. In India, there is a government initiatives, the local train running by hydrogen vehicles. Hydrogen in the aspect of hydrogen electric vehicles, the main problem is the main cost comes from the fuel cell stack. Why? Because fuel cell is in battery, lithium is more costlier. Similar way in fuel cell stack, fuel cell, platinum is used. Here lithium, here platinum. More rare earth metal and very precious metal also. That's why cost is major concern here. The hydrogen vehicles, platinum, if you reduce the usage of platinum, that novelty came into picture, like material scientists are working on how to reduce the platinum usage, thereby include some other non-noble metal catalyst to reduce the cost of the fuel cell stack during oil production. And another important thing is the hydrogen storage tank. It's not like the regular CNG tank. For example, if you have a car with a CNG tank, it is occupied by the boot space. The same boot space, same tank size, if you employed electric vehicle, fuel cell electric vehicle, only 10 to 15 kilometers can be driven. Why? Because the hydrogen what we can store inside the tank is very, very, very high power, like 350 bar and 700 bar pressure. We have to store the hydrogen gas in the tank. So in passenger segment, like 4 meter or 4.5 or 5 meter length car, it is very complex to accommodate that much pressurized tank. We utilize the most of the space in the passenger segment. That's why in hydrogen fuel cells, the bigger the tank can be stored where the vehicle having more space. It is like that. So that's why commercial vehicle, trucks, bigger long haul vehicle, commercial vehicles have more space, so that we can employ more hydrogen cylinders over the boots, over the tank, over the head of that this one, or under the chassis, or over the anything. We have bigger in size, we can store bigger hydrogen cylinders. Similar way for hydrogen train, Alstom is now using the hydrogen train for local compute. For 500 to 600 kilometers of local compute, they are employing hydrogen trains, because the train having more space on the upper side, like top we have more space, so that we employ more cylinders on the top, so that wherever the space is more for any mobility, hydrogen came into picture. So where the world stands for the hydrogen mobility, Japan and all the Germany's are all countries supporting for the hydrogen production growth. So if you see that 2014 to 2021, a drastic increase in the sales growth. People are now focusing on the electric vehicles currently in India. In Western countries, or that Japan or South Korea, German or US, China, they are more focusing on the hydrogen economy. So India's foray into the hydrogen mobility, how India forecasting the hydrogen mobility also. This shifted India focus on green hydrogen, set goal to make its e-mobility industry energy independent by 2047. The mission outcome is, first is our objective is to produce the hydrogen and store the hydrogen in a different methods and sell that stored hydrogen to other countries who are working on the automobile sector, particular mobility. See, infrastructure developing for the electric vehicles, it is challenging. If you want to develop, particularly for hydrogen, it is more and more complex. That's why our government, Indian government, anticipating to invest on the National Green Hydrogen Mission, 20,000 crores to initiatives to produce green hydrogen and store the hydrogen in specified tank and sell the hydrogen gas to the companies. That is the first our outcome, and mainly focused on the production part. And investing by governments, 88% of mission total incentive to generate green hydrogen and manufacture electrolyzers. The National Green Mission is expected to attract a total investment of 800,000 crores by 2030 and create around this much jobs. So impact on industries, how it is. Heavy duty trucks are expected to be significant in the hydrogen mobility space by 2030. It is established 12,000 FCV heavy duty trucks will be running on Indian roads. Tata Motors, Cummins, KPITs, and a lot of companies are in developing and low and zero emission propulsion technology solution for commercial vehicles in India. Tata Motors also are working on the fuel cell vehicles, particularly on the passenger, not in the passenger segment, commercial segments. Commercial vehicles includes small segment, medium, and large scale. Small includes three-wheeler, small less than 1 ton. From 1 ton to 3 ton medium, then again after 3 tons of loading payload of capacity, it comes under heavy duty. So these are the Indian government foray into the hydrogen mobility. So comparing, these are the cost comparing and some of the comparison of the FCEV versus BEV. So driving range, think about that. BEV 550 kilometer, the same thing FCEV 1300 kilometer. Why? Because this is the battery is charging or storing this much capacity. Here it is a refilling. Whenever you supply hydrogen gas and oxygen gas, electricity is produced. Whenever electricity is produced, it charges in the battery. It's a continuous loop. So it's like similar like our petrol CNG engine. Wherever when you put petrol or diesel in a charge in the fuel cells in the filling station, similar like hydrogen gas is filled in a tank in less than a minute. So then you can drive for more than 1,300 kilometers. So this is the main advantage of FCEV, and the other zero tailpipe emission. That refilling time, particularly the refilling time, needs 30 minutes to attain 80% charge, fast charging. Higher the cost per kilowatt and has negative impact on battery life. In economic and commercial viability of these innovations in BEV is unknown. So the global availability of hydrogen fuel by stations for road vehicles, particularly by a country. See, China, Japan, South Koreans, Germans, US. So it's drastically increasing the global availability of hydrogen filling stations as versus road vehicles. So Toyota Mirai provides a range of 650 kilometer, while only a few high-end BEVs can deliver around 565. So they will put 700 kilometer per charge, but practical since 565 to 650 kilometers can charge by an electric vehicle. But in Toyota, they are having a world record. Single charge more than 650 kilometers it is driven. So comparing the energy efficiency of FCEVs and BEV, in energy density wise, hydrogen is more than higher. Lithium battery is very less compared to hydrogen is having more energy density. In energy efficiency wise, lithium battery is highly efficient energy efficiency. Hydrogen, because it is generating the electricity, it is just storing the electricity energy, so that the losses of transportation transformation is very, very less. And the higher compared to the energy rate, BEV from energy well to transport, that grid connection from grid to battery, tank to wheel, the battery, then battery to electric engine, 70 to 90 overall efficiency. Here, this is how that 70 to 90% acquire here. But here, FCV energy is produced somewhere to hydrogen is produced through electrolyzer or something, then it's stored on the compression cylinders, then compression tank, bigger tank of lorries or trucks storing the high compression hydrogen to the filling stations. From the filling stations to power and fuel cell generation, like fuel cell stack. Here it's power generation, fuel cell stack to the engine, electric engines, because the electricity again produced on the fuel cell is stored on the engine, batteries, and batteries to the engines, motors. So 30 overall efficiency rate. So anticipated timeline. For example, passenger vehicle, that FCV is green color, BEV is the violet color and IC is the blue color. If you see that hydrogen ICE means hydrogen internal combustion engine. From 2015, like commercial petrol and diesel, 2015 till it is 2020, it is fading like anything. So 2030 almost we are going to drop out diesel engine, and slowly petrol engines also going to drop out by 20. So in the year on year increases, the hydrogen use of petrol and diesel is reduced. If you see FCEV, from 2015 to 2035, it is strongly acquiring more business on the FCEV. Because of that, hydrogen FCEV more popular as compared to BEVs in heavy duty vehicles. Because why? Because the storage space is more higher. If you BEVs think about similar, 2015 it is very less. In 2035, the 2030 and 20 strongly working on both passenger segment and higher vehicles also. So the fourth technology is that hydrogen ICE. After FCV, hydrogen ICE, utilizing the same engine like petrol engine, same engine, only slight modification required. Instead of petrol or diesel, we can directly inject hydrogen gas into the engine. So it's combining FCV and internal combustion engine. So that is the future scope of the future mobility of producing the electricity as well as long haul connectivity. So the overall objective of this green mobility transportation is starting from steam, petrol, diesel, then electric vehicle, hybrids, fuel cell, then hydrogen. This complete evaluation is more focusing towards on the environmental impact. So thereby reducing the carbon footprint, and the ultimate goal is to improve the air quality and usage of energy efficiency in a cost-effective manner, and along with the higher the people have to mindset that you have to focus more on their environmental safety as well as environmental concern. So this is about the complete overview of this topic, energy mobility and electricity vehicles in planning.
Sir, the session was very useful, sir.
Okay, so thank you.
Okay, once again, thank you all. It is almost 9:30 going to. Okay, it's a late night for everyone. Okay, my final thing is, once go green to make globe green. So people have to change our mindset. So go with batteries, use shared mobility to reduce the pollutant gas and improve the economy as well as the